Oh, perfect. All right. Hey, everyone. My name is Sean Levatino. I'm the principal game designer at NCSoft West Iron Tiger Studio, and I'm here to talk to you a little bit about metagame. And metagames are this sort of new thing in the industry. They're very big. They're very interesting. We're still trying to figure out what they all are. And there's been some techniques recently that can help bring some sort of formal analysis to metagames. That can be really, really helpful if you have a large sort of PvP or competitive focused game. So I'm going to talk pretty quick. This might be a little bit technical. I've got a lot of slides to cover. I'm going to skip kind of the whole obligatory casual connect self-promotion slide. I've worked in a lot of places. I've had the privilege of working on everything from PCs to mobile to Toys to Life. If you're really interested, you can Google me. Because I really want to get into sort of the meat of the talk. So 3 things we're going to do. We're going to define sort of the terms that we're talking about. I'm going to introduce Metagame Bounds, which is a very specific technique developed by someone by the name of Alex Jaffe. And I'm going to talk about how expanding that usage beyond sort of its original design into something that's a little more useful for sort of mobile games and a lot of the games that we're working on. So first thing off is defining our terms. So what are we talking about when we talk about a metagame? And this is a really, really big topic. Like I said, metagaming, the way it is now, when we think about like communities of millions and tens of millions of players, is really a new phenomenon. It didn't really exist the way it is now in games more than the last couple of years. And that's really exciting, because that means that we as developers can sort of define what this sort of field of study is. And there's really no consensus on what metagame is. If you ask 10 designers, you're going to get 10 different answers. But there's a description I really, really like from Chris Bateman, who described it as tactical and strategic considerations made outside the structure of your game. And basically what that means is, and a really good example of this is character choosing. So you think of the structure of a game as sort of like a match, like a fighting match. And so the choices you make outside of that, what character am I going to pick, and basing that decision not on the game itself, but on the person you're playing against, basing that on the community you're part of, basing on, different characters have different strengths or weaknesses against each other, so who's really popular. If I know one character is popular in the community, I might pick another character. And these decisions are happening for things outside your control as a developer. It's happening because of the way the community is reacting to your game. And that's what makes this really special. And really different and very new. And 2 things that really come out of that is that metagaming, 1, requires community. We as developers don't really have direct control over our metagame. This is something the community builds for itself. And so, consequently, it doesn't really exist until our game is in the wild. And this is going to be really important once we start developing these games. People talk about esports, competitive sports. You don't really know what you have until you've put it out there. The other thing I was going to say is it requires competition. You can technically have metagame. I think this is a great argument if you want to have it outside of a competitive space. But it's kind of for the sake of this talk, we're going to say there's this idea of this repeated competitive cycle. A fighting game, a match, a MOBA match, an Overwatch match, things like that. And that cycle, all of the things that happens outside that cycle is kind of what we're looking at. The other thing we want to talk about is healthy. What does healthy mean? So there's 3 things that I'm really sort of going to talk about. 1 is no dominant strategy. That means that as players are trying to make this choice of what character do I pick, what team do I put together if I'm playing a MOBA, that there is no one clear choice that is always best in every situation. If players go into your game saying, I'm always going to play this character because no matter what choice my opponents make, it doesn't matter, I have a dominant strategy, that's not healthy. We really want to avoid that. The second thing is ergodic, and that's a really fancy mathematical term for saying we want the metagame to shift over time. And we want this idea that like all of the possible spaces that our metagame balance could be in, we want to eventually kind of hit all of them. And I think a really sort of real-world example is this for anyone who's played Star Wars Galaxy of Heroes. For a long time, there was Ewoks as a class were just kind of useless in the game. Like, you had a bunch of characters, and they had some skills, but no one ever really built an Ewok comp because they just weren't really good. And then some changes happened to the balance, and suddenly there were specific Ewok comps that were amazing, and people were just destroying other people with them. And then, eventually the meta changed and sort of moved away from that. So the idea that what is considered dominant, what is considered a really great build, we want that to shift. And we want that over the time of our products to sort of hit all the possible spaces so that people who really like Ewoks just because they really like Ewoks, they get a chance to sort of be on top for once in a while. And the last thing I'm going to say is non-linear, and that's sort of just a way of saying Players shouldn't be able to look at your game and sort of solve the questions of best strategy before they've played it. Your game shouldn't be so simple that they can sort of sit there, build a model, run the math, and before they've ever played the game, they know exactly who's going to win and who's going to lose. You want there to be some mystery sort of going into it, but at the same time, you want it to make sense afterwards, where if one comp fights another comp and one comp wins, you're like, oh, this is why. It's very clear why one is dominant. So this is sort of an overall look at health. I think for the sake of this talk, because we have such a limited amount of time, there's obviously a lot of information, we're really just going to look at the no dominant strategy part. That's kind of what we're going to focus on for this specific part. Because when you look at metagames, like I said, metagames are huge. They're very complex. And as designers and as creators, we only really affect the structure. So we build the structure, we build the balance, we build the features, we build the mechanics. And out of that, that sort of affects the balance in very sort of difficult to understand ways. And then the balance drives the perception of the game through the community, and that drives sort of the community aspect of it. So we as developers really control this one. This is sort of where the value is, and it sort of like follows down the chain. So for this specific talk, I really just want to focus on this sort of joining right here between balance and perception. It really gets to the question of, can we use data to better understand how players perceive the balance of our product? Obviously, I think the answer is yes. That's why I'm on stage talking to you. And I want to sort of talk about one way we can approach that. So what we're going to do is move into sort of the meat of this, and this is introducing Metagame Bounds. And this is a sort of a very specific thing. This was developed by, there's a formal approach for measuring metagames. It was developed by someone by the name of Alex Jaffe, just previously of Spryfox. And he originally presented at GDC 2015, and he built it originally for fighting games. And I saw this talk, it sort of blew me away. I've been wanting to use this technique for a really long time. And what really struck me is that this was really developed for this sort of one versus one, pretty straightforward strategy games. And I'm saying, okay, can we expand this to games with more complex strategies? Can we bring this into games with multiple players, with teams versus teams, where you have hundreds of characters to pick from? Can you bring it into games where characters have progression? It's not just a sort of one cycle where everyone starts at the same level. So I'm going to start with a sort of a very basic introduction to what Metagame Bounds is with an example, and then we'll sort of go into examples of how we can bring that into sort of more modern complex games. So to start off, we're going to build like a sort of fake game that's very simple, and I'm going to show you sort of how this technique works. So we're going to have a fake game. I'm going to call it Meme Fighter 9000. So imagine this very, very simple one versus one fighting game, and you've got only 4 possible characters you can pick from, right? So you've got like a robot, you've got a ninja, you've got a pirate, and you've got a zombie, right? The most basic game you can think of. And so you put this game out, you've got whatever your rules are, whatever your mechanics are, whatever you define, hit frames and counters and all that stuff doesn't really matter. What matters is you build this game, you put it into the world, and you have players playing it. And you're recording the data, you're recording all this matchup data. And you can sort of build this matchup chart. You can build this idea from real players how often different characters sort of defeat other characters. And you can see sort of, player A on one side versus player B on one side, and a robot obviously against another robot of the same skill has a 50% chance all the way down. We'd say a pirate would have a 40% chance of beating a ninja on average. And there's something really important about this is that this is based on the concept of players of equal skill. This is assuming players of equal skill. And we'll get into that when we start talking about the data recording aspect of it. But these are basically strategies. I, as a player, need to pick what character I'm going to play as. And I'm going to choose that strategy based on who I think my opponent is going to play as. So we've got a graph, we've got player strategies on either side, we've got sort of a payoff matrix in sort of in the middle based on real data. Like, this is game theory, right? I mean, anyone who's been to a Frank Lance talk has seen these sort of graphs before. And when we have game theory, we have math. So don't worry too much about the math. I'm going to go over it very quickly. You don't necessarily need to worry about it. Just sort of know that it's coming. So looking at this matchup chart, what we can do is we can say, hey, can we sort of do some magical math stuff and say, what is the expected as a player? What is my optimal strategy? How often should I pick different characters, the robot versus the ninja versus the pirate, based on who I think will be matched up against. And the really nice answer is that we can. So basically using what's called linear programming, we can sort of push these numbers through, and again, don't worry too much about the math, but we can come up with essentially optimal strategy that says, hey, as a player, if you want to be an optimal strategy, you should play these individual characters exactly this often over a long period of time if you want to have like the optimal win rate, assuming you're playing people of your sort of at the same skill. But there's a problem with that, and that problem is that nobody plays purely optimal strategy, right? I mean, players are humans, we're not robots. And especially when it comes to fighting games, we tend to invest ourselves in specific characters. You know, people will pick characters because they really love them, or they like the moveset, or they like the character design. And especially for, if you think of a really deep game like Street Fighter, people will spend months and years with a specific character just learning all the ins and outs and the mastery of that character. So they're not just going to switch characters around all the time. So the question is, can we get a better model that sort of really more closely matches the way real humans play? And so again, understand, like, is our game balanced? Is our metagame sort of healthy for all of the players? So to do this, we're going to look at like one specific character. We're going to look at our pirate friend, and we're going to sort of look at his win rates against all the other characters. And what we can do is we can modify that original linear programming a little bit. And we can say, don't find me the optimal for pirate. Don't tell me exactly how many times to play pirate out of 100 games for the optimal win rate, because I really like the pirate. I just want to know, how often can I play the pirate and still sort of be a successful player? And so what we can do is, we can modify that linear program a little bit. We can force it to simulate you playing a specific character exactly, you know, 1% of your games, 2% of your games, 3% of your games. This is all programming. This is a couple lines of code in Python. And we can sort of build this graph. And what this graph is showing us is saying, if I were to play, and I sort of divided by 5%, 10% as opposed to 1%, because it's a little bit easier to see. But you can do it by 1%. And you can say, okay, if I played the pirate exactly 5% of my games, then I would probably win around 60% of my games. That's pretty good. And you can see sort of, okay, if I played 10% of the games, and I, only 10% of the games, so 90% of the time I'm playing other characters, oh, now I'm getting better win rates. And eventually, if I play the pirate too much, if I'm only playing the pirate, then I'm actually going to be losing a lot. And so we can get this idea of saying, okay, what do we consider fair? As a player who really loves a pirate, what do I consider balanced and healthy for my experience? And this is a little bit arbitrary, but we can sort of basically make a line. There we go. So we basically make a line. We can say, okay, about between 40 and 50%. And again, we can set that whatever we want. We can say anything above this line we consider healthy. We can get this whole range of play rates and play percentages where if you play the pirate around that percentage of time, you will, in general, be successful about 45% of the time over your entire career. And we can do that for all of the characters. And so we can build this kind of a graph. And this is the Metagame Bounds. And what this does is, I'm going to take a little sort of minute to show this. It doesn't show up super great on this screen. But we have, for each of the characters, we have sort of a left extent and a right extent across basically from 0% to 100% of the play rates. And so we can see across the entire sort of player base which characters are necessary to sort of be like a high-value player, to be a winning player, obviously against sort of a general case players of your same skill. So what this is telling us is that the pirate, if I never play him at all, if I play him 0% of the time, I'm in the green, so I can be reasonably successful, up to about 50% of the time. That's this right extent. So if I play anywhere from 0 to half my games as the pirate, whatever I'm doing the rest of the half of the games, I have the possibility of being successful. But if I concentrate too much on this character, then I'm not going to be winning a lot. And so we can sort of build these sort of sensibilities out of this where there's basically 3 types of graphs that we come out of, which is sometimes dominant, which is like, okay, you can use this character a lot and still get away with it. You don't need to switch it up. He's pretty strong. We have always excluded characters, which is this poor robot over here, which is just, this character is so bad, you should never play him. That's really bad. We want to look for those. That's like, okay, why are players not winning with this character? Even if they're still winning sometimes, why would it be optimal to never play this character? So we want to sort of look for these as sort of signals and lenses being like, there might be something about this character we want to look at for balance reasons. And the other one is this always dominant. So when you see this left extent, actually pull away from 0 and start going forward, what that's telling us is that this ninja character, for you to be a successful player, for you to be above 50% win rate, you have to play this character at least 40% of your games on average. And that's really bad because now players feel like they're forced to play that character. And anyone who's played certain games, there's certain metas where you're like, I don't like this certain deck, I don't like this certain build, but I feel like I have to play it or else I can't win a tournament. And that's a big red flag when you start seeing this type of characters in your graph. So that's kind of understanding metagame bounds a little bit. And so I want to talk about sort of expanding that usage. So like I said, this is built originally for single 1-versus-1 fighting games. You have characters, they don't level up, they don't power up. Your power rating is always the same every game against an opponent that's fairly matched. But we build games that are not like that. We build games with progression systems. We build games with teams. We build games with like multiple team comps. So how can we sort of build this out into sort of more of the games that we're building as an industry? So for an example, I'm going to look at DotA 2. Very popular. They also have a lot of open data, which makes it nice for doing analysis. And so okay, this is significantly more complex. How would we adapt something like Metagame Bounds to something like DotA 2? Because now I've got 5 players versus 5 players. We've got a sort of standard MOBA map where there's multiple lanes, and not all the characters are fighting each other all the time. It's not quite like Smash Brothers where all of them are scrumming together. How do we build a concept of strategy on this? And there's a couple ways we could do it. First one might be, do we just look at unique matchups, like every possible combination of 5 characters versus 5 other characters? And that might be sort of like technically the most correct, but you're going to have 128 million rows versus 128 million columns. It's going to be an enormous graph, and it's sort of one beyond. Even if you could find the computer to do that information, you come up with a couple walls with that, which is one. You wouldn't even understand it. Looking at it as a designer, it'd be like, okay, here's 128 million rows, there's 128 million columns, find ones that are not balanced. Okay, what do I do with that? That's way too much. The other thing is that when you're trying to sort of devolve your strategies, you want the right granularity, because if you get too granular at this level, you're talking about 128 million squared possible data points. So your information density is going to be really low. The vast majority of those data points, no one's ever played a game like that, so you just have no data. So you want to bring down your dimensionality a little bit so you can get more dense and more repetitive data within the same space. So what about role? Role might work. Valve sort of has 9 specific sort of like predefined roles for their characters. So that's 9 pick 5, you get 1,200 rows. That's much more within the realm of reasonability for something you could put a computer for, and you might be able to sort of wrap your head around it as as a PM or as a designer. But the problem with roles, at least for DotA, is that characters can have multiple roles assigned to them. So it's like, it's not one role per character. Even if we see certain roles, have an outsized balance, then is it all the characters? There's only characters with only that role and certain other roles. It might not really work. So it's like, well, maybe we do primary attribute, because there's only 3 primary attributes. Now we're the opposite of granular, right? You've got, 21 rows. That's tiny. You can just put the whole thing on one screen. So now we've gone maybe a little too far to the other way, which is like, well, is primary attribute really meaningful? We've got 111 characters across 3 primary attributes, just 30 characters per attribute, who sort of has that as their one attribute. Even if we saw that strength generally balances stronger than intelligence, when you have 30 characters that fulfill that, what would you do with that? So that might be too little granularity. So this is just sort of illustrating that how you decompose your game into strategies. What is the player thinking about when they sort of pick their game, when they sort of go through the game, really matters. And there's no clear, sort of set way to do this. This is really game dependent, and how you do it for your game is going to be completely different how someone else does it. But for the case of DotA, what we want to do is let's just do the simplest thing we can, which is really simple. So we're just going to mimic a 1-versus-1 matchup chart. For all the characters who play a very specific lane. So we sort of did this, and we came up with a chart, and this is very, very constrained to specifically characters who play in that middle lane. So if you pick a character and you happen to play in the middle lane, then we're going to look at whether or not your entire team won the game. So again, it's a very sort of like vague way of thinking about strategy, but it lets us at least build a chart that we can look at and sort of wrap our heads around. So what you're seeing here is obviously not all of the characters in DotA. There's way more than here. But you're just looking at sort of like the top, middle, and bottom 10% of the roster in terms of balance. And actually, for the most part, looks pretty good. Like the worst characters, are still reasonable to play. You can play everybody in the game and still basically feel pretty good. Some of the middle characters are getting a little bit better, and then the top characters you can see you're starting to pull away, except for this guy right at the top. And I'm sure you can see that it's Omni Knight. And Omni Knight, when we looked at all this data, is crazy overpowered. I mean, basically what we're saying is like, you need to play Omni Knight at least 35 to 40% of your games if you want to win more than 50% over a long period of time. And that's really kind of crazy because Omni Knight is really not that strong of a character. He's a support character. Anyone who's played Dota knows that he's not a guy who's going to go out and like stomp people in 1 versus 1. So this is, like I said, this is a lens. It's not going to tell you what's wrong with your balance, but it's going to give you a place to look. It's like, oh, is he maybe too strong of a support character? Are there certain characters he combines with where he makes people invincible? He can make your team invincible. He has these special powers that maybe sort of combo in a really, really strong way. So it's a way of saying, like, there's a fair amount of caveats going on with this. Obviously, this looks at a very narrow portion of the experience. We're judging, an entire team based on the sort of like this one middle lane, which is like 1/5 of your team. Like I said, Omni Knight looks very OP in the data, but we know people who play the game know that he's really a support character. If you look at his pick rate, he's actually towards the bottom of pick rates. I think he's below 50%. He's not a very popular character, but the people who do pick him do very, very well with him, and the team does very well when people pick him. So like I said, this is sort of a very broad lens to be able to look at your games and look at the live data for your games and sort of understand, like, okay, is there something we want to look at? If you're at Valve, you're like, okay, maybe we want to look at the way Omni Knight's skills sort of mix with other ones. And then, so that's just kind of looking at specifically at Dota. So the idea is like this technique is still very, very new, and there's a lot of work to sort of be done with it. So obviously looking at other games where this could fit. Overwatch is a really great example. 6 versus 6, you've got a much smaller group of characters to pick from, 21 heroes. You could look at unique heroes in the sort of matchup, but that's tough because players switch heroes a lot. It's not like a Dota or a League of Legends where you pick a character and you have it for the entire match. So how do you model players who jump characters all the time versus players who don't? You could look at unique role for the character. Overwatch only has 4 roles, which is really great. But again, people, when you look at a support, no one really says, I need Lucio in a team. They say, I need an attacker, or I need a support character. So you can bring the dimensionality down, but there's each visual way, each sort of technique we use to sort of build a strategy has some drawbacks. Clash Royale is another great one. You can't just look at every unique deck because there's 13 billion possibilities of decks. It's way too insane. It's way too insane to sort of figure out. So the question is, like, what can we do? Like, obviously as a player, Clash Royale has the problem of there's not really open data for it yet. But is it if a card shows up in a deck, then you've only got 73 rows. That's way more reasonable. You can sort of do that as a designer or as a developer. But then the question is that meaningful? If I happen to work at Supercell, I'd be like, well, I'm looking at, does the player win if this card shows up in a deck? Is that helpful? Maybe, maybe not. It's really the interaction between the cards. So the big challenge with this is it's a very powerful technique, but building strategies and building just the exact right way of decomposing our data really is going to sort of determine its effectiveness. The other thing to look at is experimentation with mobile RPGs, specifically ones with persistent character advancement. So think of like Star Wars Galaxy of Heroes, where now you've got this 5 versus 5 team matchups, you've got tons of data, you can look at it, but now you've got characters that are leveling up. They have tiers, they have levels, they have equipment grinds. As a player, we're grinding that. So, because my Darth Vader may not be the same as your Darth Vader, that's going to affect how I model it. And so we don't necessarily have answers to all of these, but this sort of is used to illustrate sort of some of the challenges we need to use to sort of use this technique, this sort of cool formalized technique, in sort of the games that we work on. So kind of takeaways. Obviously, more data. More games should have publicly available data through their API so that anyone can sort of do this analysis. Valve has been really great with this with DotA. Riot has been great with this with League of Legends. I think Clash of Clans has this, but not Clash Royale. So just more games as an industry, the more we start doing this as an industry, the more these techniques, people can build on these techniques. So that's kind of like the first takeaway, is we just need more games with publicly accessible data. But beyond that, like Metagame Bounds is a very useful formal technique. It can be used if you have that data. If you have a game in the wild, you have players playing it, you can start experimenting with strategies, try different ways of decomposing things, see what comes out. You might have some where your metagame seems wildly overbalanced in one and looks sort of fine in the other one. So it's up to you as the developer to sort of own like that process and understand what is meaningful for your game. The other really important thing, I sort of touched on this briefly, I'll talk a little bit now, is that not all users are created equal. Part of the caveat of this technique is that it really relies on the assumption of the matchups between players of equal skill. So when you start pulling data from your users, you have to be very sure to sort of segment your users by skill level. So make sure that like you can control for that as much as possible. Always take players from the same PvP tier or from the same skill level or same ELO ranking, however you're doing your rankings. Try and control for that as much as you can. And like I said, for all formal techniques, this is true. They can point out where problems might exist. This is sort of true for all data analysis. They can sort of point out where problems are, but they can't tell you how to fix them. Only your team knows how to fix them. The balance of these games are ridiculously complex, and no formalized technique is ever going to tell you fix this thing. It can only tell you where there might be a problem. So I've got about a minute left. So really quick acknowledgements. Huge thank you to Alex Jaffe. He is the guy who sort of built this technique originally. I'm just sort of taking it and running with it. All of the code, all the Python code that's used to build those charts is available on his GitHub repo for free. It's very easy to run. You just sort of put in Excel and it gives you a matchup chart. His original talk that goes much more into the sort of basis of this technique is available on YouTube from GDC. There's a little QR code that's much easier to type out than a YouTube link. If this thing is all interesting to you, I really highly recommend you check out his talk. It's really great. And secondly, thank you to Frank Lance. You can't talk game theory or formal techniques without bringing up Frank. NYU Game Center, all of this is sort of built on the work he's done to sort of get us as an industry really into game theory. If you have interest in sort of like game theory and the idea of like mathematics in game balance and game design, again, he has a talk also from GDC. There's a link to that. Really fantastic talk. Goes into the history of how some really, really smart people almost destroyed the entire world because of game design. It's a really great talk, kind of terrifying. And with that, I'm out of time. Thank you.
Thank you, Sean.